Using NMR and IR spectroscopy, I was able to conclude that the molecule given to me was isobutyl acetate. The first thing I did with respect to analysis was to identify the infrared spectrum of the molecule to figure out what bonds compose the structure. The IR spec, according to the IR spectrum table, has a carboxylic acid, meaning that there is a CH bond in the wave number of 3000, a CO single bond in the wave number of 1200, and a CO double bond in the wave number of 1700. This can be seen in the given spectrum. Given the information that there are two oxygens in the molecule, C10H18O and C10H16 could be ruled out from the food hydrocolloids analysis. To further narrow down the list of molecules, I integrated the signals and identified the splitting of the protons on the NMR spec. As seen in the NMR, there are 3 signals of proton splitting, A, C, and D, and 1 signal, B, where no splitting occurs. The carbon double bonded to the oxygen, which was determined from the IR spectrum, likely explains the region of zero splitting because the double bond isolates the protons in that region. The isolated region B is most likely a CH3 group on the end of the molecule. Because there is no splitting, the CH3 group wouldn't have any neighboring hydrogens. Therefore, being on the end of the molecule next to the carbon double bonded to the oxygen ensures that there are no other hydrogens in its vicinity. To further analyze the molecule, I integrated under each signal divided by the smallest integration and multiplied by 2 to get all the values to whole number integration. The D signal on the NMR corresponds to an integration value of 6 and is split by 1 proton as seen in the signal, meaning there is likely 2 CH3 groups determined by the integration that are neighboring 1 CH determined by the splitting. The signal for A had an integration value of 2, corresponding to a CH2 closer to one of the oxygen atoms, which could be determined by the shift. Unlike the real NMR, the expected NMR would most likely have shown signal A as only having 2 peaks indicating a split by 1 proton instead of 3 peaks indicating a split by 2 protons. A in this image refers to signal A and C refers to signal C. The signals corresponding to B and C had some issues with the integration. My data gave me integration values of 4 and 3 respectively, however these numbers put the number of hydrogens of the molecule to 15, which is not characteristic of any of the given molecules in the hydrocolloid food analysis. By using the HNMR feature of ChemDraw and seeing that 4 signals is characteristic of a molecule with 12 hydrogens, I was able to further narrow down the determination of the molecule. The molecule, considering the given information in the spectrum data, was identified as having 12 hydrogens, 2 oxygens, and 3 CH3 groups. The only molecule in the list of food hydrocolloids with all 3 of these characteristics is isobutyl acetate. The expected spectra of isobutyl acetate would have had integrations of 3 for signal B and 1 for signal C, indicating that there is a CH3 that doesn't experience splitting and there is a CH that exhibits a lot of splitting. This would have given the proper number of hydrogens for the molecule. Also, the actual NMR showed that the third signal had a slightly smaller shift than the expected. In the actual NMR, the third signal is around 1.5 ppm. In conclusion, the expected NMR and the actual NMR had a few differences in terms of integrations and shifts. However, through IR and NMR analysis, the food hydrocolloid isobutyl acetate could be determined.